Since it's underneath the square root, we're going to subtract 1 and we get x is what? Greater than or equal to -1. So that means this, from -1 to infinity. We take the union of that. In other words, we take the smaller of the two. The intersection of that. Which one of those is smaller? From -1 to infinity, right? So we're going to take the one that's smaller, and that's actually my domain. Okay? We always pick the one that's least inclusive. That means the smaller of the two domains. Does that make sense? Anybody have any questions on that one? Let's do f minus g. F minus g is going to be what? X cubed what? Minus square root of x plus 1. Are the domain and range going to change at all? It's not, is it? So what's the domain of f minus g going to be? If it doesn't change, then we're using the same domain for f and the same domain for g, aren't we? So if we're using the same domain for f and the same domain for g, what's the domain? What's the smaller of those two domains? -1 to infinity. Once we figure out the domain for f and the domain for g, if we're using the same f and g, it's going to be the same domain almost all the way around. Okay, so what is f times g going to be? X cubed. And did the domain or the range change at all? No, and we can still multiply, so what is the domain of f times g? Still -1 to infinity. And last but not least, f divided by g, what is that going to look like? Now, the domain is going to change for this one slightly. Because that g, the square root, is in the bottom, it can no longer be equal to 0, can it? Does everybody see that? Look what we had here. We had x plus 1 greater than or equal to 0. Can we include -1 down here? If I plugged in, do you see what I'm talking about? We've got this as a closed bracket. We're saying we can use -1. Can I plug in the -1 right here? No, it's going to go to 0, isn't it? So how am I going to change this so that I don't include -1? What can I change this bracket to? Parentheses, right? So this, instead of being bracket -1 to infinity, the domain is going to be parentheses -1 to infinity. Okay? So the domain of f over g is going to be -1 to infinity. All right? Positive. What did I write right here when it had to be positive? It was under a square root symbol, so I took what was under here and I said it what? All right, so composition of functions, you've done this before too in Algebra 2. This should be a little bit of a review. F of g, this is not a times symbol. This is not multiplication. So make sure you make a note that this is not multiplication symbol. It means of. F of g. Okay? So this is of. Basically what it means is this. We're going to start with from the inside out. We're going to start with whatever goes into g. Because notice what f of g means. F of g can be written as f of g of x. So I want you to follow this. G of x means we take an x value, doesn't it? We're going to take whatever the x is and we're going to plug it into G, right? Isn't that what that means? If we put a 2 here, we would be plugging a 2 into this function G. That is an input. That input X goes into G. It brings you something out. That guy is now in the parentheses for F, which means that whatever's coming out of G gets stuck into F. I always say work the inside out, because basically what we're going to do is this. We're going to take the X and plug it into G, and then whatever we get from that, we're going to plug into F. Does that make sense? Inside out. So that's what F of G is. Now guess what? G of F means the opposite. G of F of X means this way. We would take X and plug it into F, and then plug that into G. So whatever second comes first. Does that make sense? All right, so let's look at this. Composition of function says F of G of X. So we're going to take G, whatever that is, and plug it into F. Everywhere there's an X, we're going to plug that. So what is F of X? Let me just show you the whole thing. F is X squared plus 2X minus 1. So what we're going to do instead is everywhere we have an X, we're just going to leave a space. And guess what we're going to plug in there? What does it say to plug in? It says to plug G in, doesn't it? So whatever G of X is, which in this case is 1 over X minus 2, guess what? That goes in here, and that goes in there. So we're going to have 1 over X minus 2 squared plus 2 times 1 over X minus 2 minus 1. And then we're going to clean it up a little bit. 1 squared is 1, so we can do 1 over X minus 2 squared. 2 times 1 is 2, so 2 over X minus 2, and then minus 1, and we can leave it that way. Now, we have to figure out the domain. Is there anything, looking at this new function, is there anything I cannot plug in for the domain? Is there anything that's going to make the denominator go to 0? I feel like you don't even know what I'm asking. Is there anything that you can plug in right here or right here that would make this expression go to 0? 2. If I plug in a 2 right here, so I can't use 2 in my denominator, can I? Or in my domain. So the domain is everything except what? 2. That means we go from negative infinity to 2, and then from 2 to infinity. In other words, X cannot be 2 really becomes this. Does everybody understand how you write it if X can't be 2? All right, so instead of F of G, this time we're doing G of F. So now we're going to take F of X and plug it into G. So now we're going to rewrite G, and everywhere there's an X, we're going to put a parentheses. So what is G? 1 over X minus 2. So this is going to become 1 over something minus 2. And guess what that something is? Is everybody seeing that? That's going to be whatever F is. So what is F? Yeah. So we're going to plug in X squared plus 2X minus 1. And then we'll clean it up. So this becomes 1 over X squared plus 2X. And then we got a minus 1 minus 2. So that would be minus 3, wouldn't it? All right. Now for the domain, we got to figure out if there's anything we can't plug in there. And you know how we figure that out? We factor it. So what does X squared plus 2X minus 3 factor into? What do I multiply to get negative 3 but adds up to positive 2? Plus 3 and minus 1. So now What are my x's? What are the things that x cannot be? X can't be what there? -3. And what can't it be here? Okay, so let's write our domain then, using that. So we know our domain goes from -infinity to which one of those? Which one's lower? -3. And then goes from -3 to 1. And then from 1 to what? Yeah. Is this starting to make sense? Why don't you try very quickly, before we move on, why don't you try f of h? So you're going to take h of x and plug it into f. So rewrite f, leaving your parentheses, and then plug h in. And then we'll talk about the domain for that one. And then check your work. See if you got the right answer. What does a square do to a square root? Eliminates it, doesn't it? So that's what happened here. This and this went away. So 3x just came down. All right, so now we have to deal with the domain. The only thing that's going to affect the domain is right here. So if we see a square root, what do we need to do? Take whatever's under the square root and set it what? It has to be positive. So if it has to be positive, what do I write? What did we write back in the other one where it had anything here? Take that 3x and set it greater than or equal to 0. So what does x have to be? And then solve for x. How do I solve for x? Divide by. So x is greater than or equal. What is 0 divided by 3? So x just has to be greater than or equal to 0. So what does that mean about my domain? How do I write that? Greater than or equal to 0. Parentheses or bracket? Let's start there. Bracket. What's the lowest number it can be? And then where would it go? Okay. Everybody good? All right. Let's jump on to the next page. Let's talk about what happens when we decompose a function. In other words, guys, we're looking for what's inside and we're figuring out what's going to happen. We replace it with an x. So what is inside here? Does everybody see inside here would be the x plus 3, wouldn't it? So inside is x plus 3. Well, what is being done to the inside? So we're going to take this, turn it into x, and apply whatever happens. In other words, if we're trying to turn it into f of g of x, the inside is our g of x, and the outside is our f of x. Does that make sense? Because look, inside is g of x, outside is f. Do you get it? All right, so I want you to look at B and see if you can tell me what's the inside thing. This is sort of like being in parentheses, isn't it? In other words, we could write it as 1 divided by x minus 5. Now, doesn't that put that inside? So the inside, my g of x is x minus 5. Now tell me how I rewrite the other. What would the outside look like? Just rewrite it. We did, instead of x minus 3, or x plus 3, we just put an x, didn't we? So instead of x minus 5, what would we put there? So this becomes 1 over x. Do you see the pattern? Now try C. What is the inside? So what is the inside thing? What you write down for inside? Yep. X plus 2. That's the easy part, isn't it? Now, how did you rewrite the outside? Yep. Square root of x. We would take what the inside is out and just put in an x there, don't we? All right. So now, what is the inside on D? Good. So how would we rewrite this? You guys got this. X squared minus 4x plus 5. Good. Decompositions are easy. All right, so now it says, write H as a composition of functions in 2 ways. So we can take the inside, right? So the inside is my f of x. So what is f of x going to be? Right? So then what would g of x be? If the inside is 3x squared plus 1, what would the outside be? Yeah. So the f is always the inside, right? If we're doing this at the f of g, and this would be my outside. Okay? And I don't care if you know how to do it 2 different ways. I just want you to be able to do it 1 way. Okay? So we're good with this. Now, how do we do this? F plus g of 3. We're going to rewrite this as f of 3 plus g of 3. And we're going to look on the graph of f of x and see what f of 3 is. Do you remember how to do that? This is the graph of f of x, isn't it? So at 3, what is this function equal to? So we're going to go to 3 and go up here, and this is what? What is f of 3? 2. So this would be 2 plus, and then we have to do the same thing for g of 3. We go on the g graph, we go to 3, and we say g of 3 was what? 1, wasn't it? So what is 2 plus 1? Okay, so what about f times g of 1? This would be f of 1 times g of 1. So I want you to look on both of those graphs and find f of 1 and find g of 1. And then multiply them. Did you get it? All right, so how would we do f divided by g of 0? We'd find what? F of, and divide it by g of 0, wouldn't we? So what's f of 0? F of 0 is 4. G of 0 is, so 4 divided by 4 was 1. Do D for me, or let's do E, F of G. So we have to do G of 4, don't we? So we're going to find F of whatever G of 4 is. So what is G of 4? G of 4 is 0, isn't it? So G of 4 was 0. So now we have to find F of what? 0. So what was F of 0? Do you see how this works? So can you find G of F of 2? Find F of 2 and figure out what that is. What is F of 2? F of 2 is 0. So really what we're looking for is G of 0. And so what is G of 0? 4. All right, does everybody understand how to do that? Okay, so I'm going to amend your homework a little bit. We're done with the notes for now. That's as far